Hello, and welcome once again to AP BC Calculus with Henry Lombino. It's been a while, guys, so we're back again, and now, guess what? We're studying for the AP exam! Yay! Joy to the world. I know you all are really excited, and I'm really excited, sort of. So let's get right to it. So we're going to be going through some free response questions of the AP exam. This is from 2001. It's question number 1. It's in the calculator section, and as you can see, it says very nicely, graphing calculators required for these problems. And so let's take a look. These questions are broken up into usually 3 or 4 parts, each one worth a different amount of points. And you get different things. You actually have to write out stuff on them, and you get certain points for certain things. So you might have the equation right and then get the answer wrong. So you might get 1 point, but not the point for the actual answer. So let's see what we can do here. All right, so let's go through how to do some of these problems. So let's do number 1. So number 1 here. First of all, okay, so we have at time t, a particle moving in the xy plane is at the position x of t, yt, where xt and yt are not explicitly given. For t is greater than or equal to 0, dx dt equals 4t plus 1, and dy dt equals sine t squared. At time t0, x0 equals 0, and y0 equals negative 4. Okay, so this is a parametric problem. Alright, so let's look at this. So, oh dear. Okay, so first of all, we're going to find the speed of the particle at time t equals 3 and find the acceleration vector of the particle at time t equals 3. Okay, so let's figure this out. Okay, so now to find the speed, we have the speed. So to find the speed, we have to use the equation. So part A asks for the speed of the particle at time t equals 3 and find the acceleration. So to find the speed, we have to use this equation that we have, which is the square root of dx dt squared plus dy dt squared, which is essentially using the Pythagorean theorem. We are given the speed in terms of y and the speed in terms of x, and we're trying to find the actual speed. So we use the Pythagorean theorem to find the actual speed s. So we plug into that. So we will plug in our different equations into that, and we will get our answer. Okay, so now you can see it. So I basically have substituted in the equations that they give up here for dx and dx dt and dy dt into our equation to solve for speed. I've then plugged in 3, as you can see here, 3 and 3 for t, because it is asking for the speed of the particle at time equals t, and then I've done it out, and then eventually we will plug that nastiness into a calculator because we can do that, because this is in fact a calculator problem. And when we do such a thing, wait, I'm doing this right now, I'm just making sure my calculator's set to radian. Yeah, make sure your calculator's set to radian. You don't want to go through that crap of being like, oh, I got an answer, oh wait, I was using degrees, or when I should have been using radians. If it doesn't specify, use radians. And then, okay, plus 169, and the square root of all that. No, bastards. And we get the answer of 13.006. And there we go. There is our answer. So so pretty simple for part A. Oh, but we haven't finished part A. We're still looking for the acceleration vector. So what is the acceleration vector at time part equals 3? Well, the acceleration vector, so you find, if it's a vector, you want to find the two acceleration in terms of y, and the acceleration is in terms of x. So we have the velocity vectors dx, dt, and dy, dt, but we want to find the acceleration vectors. So that's going to be the derivative of. Sorry about that interruption. So now we've finished. So now we're going to find the derivative. So now to find the acceleration, as I was saying, we have to find the derivative of dx, dt, and dy, dt, and that will then. So we have 4t plus 1. We have dx dt equals 4t plus. So now we have d squared dx over dt squared equals 4. Okay, and then dy dt equals sine of t squared. Now we find the derivative of that is going to be equal to we apply the chain rule. We have cosine of t squared, and then we have the derivative of t squared on the outside, which will be 2t. So yeah, and then we plug in, and then we have to at time t equals 3, so this is going to be equal to cosine 9 of 6 times 6. So, and that is equal to cosine 9 times 6. It's equal to negative 5.467. Okay, and then we put that into vector form, so it's going to be 4 negative 5.467. There you go. There's part A, done. Alright, so now let's move on to part B. Part B is going to be take a little bit faster. Okay, so part B, we're supposed to find the slope of the line tangent to the path of the particle at time equals t equals 3. So what are we looking for? What is the slope? So the slope is actually dy dx. Now how do we find that? Well, we have dy dt and we have dx dt. So what we can do is divide those by each other, and then the dt's will cancel out, and we will be left with dy dx. Okay, so let's plug and chug it. So let's plug and chug that. So we have the equations for dy dx. So we're going to have sine of t squared over 4t plus 1. And then we're going to plug in 3. So we're going to have sine of 9 over 12 plus 1. Which is going to be sine of 9 over 13. And when we plug that into a calculator, sine of 9 divided by 13, we get equals 0.032. Done. That was easy. That was pretty easy. Okay. Now, so that was pretty easy. Nice and simple. So now let's do C. Find the position of the particle at time equals t3. So this is a little bit more difficult because because as it says in the problem, xt and yt are not explicitly given. We have to find equations for x and y. And how do we do that? Well, if we're given x, dx dt and dy dt, we have to find the those are the derivatives of xt and yt, so we have to find the antiderivative of those. And so to do that, we have to find the integral of those. So let us do that. Alright, let's do that. Okay, so those are the integrals that we need to find. And actually, cool thing about those, the dt's can actually cancel, so you're actually just looking for that. Weird as it looks. That is what your integral, that's an integral sign there. You might think, oh god, now we have to like figure out the integrals by hand using algebra. Okay, well, let's get this in. No. No, you do not. And here is why. So, you're given that integral, that's all fine and dandy. You're given that integral. Remember, this is a calculator problem. You don't need to use actual algebra to solve this problem. You can solve this using your calculator, and you've shown them that you know what you need to do. You actually don't need to show the actual work of finding the integral. They're just looking for the answer to the problem. So you can just plug this into your calculator using f int, and you will find it out. Okay, so let's do that. All right, so we can just plug that into our computer and be completely done, but we're not actually, because if you recall that when you plug your f in, you need a starting and ending value. Now the start of this, it's find the position at time 3. So we know the ending point is going to be t equals 3. So that's going to be the end point. The start point is going to be 0 because we're going to go from 0. However, that changes depending on what x or y is at point 0. But luckily they do give us that. They say x0 equals 0, x of 0 equals 0, and y of 0 equals -4. So what you're going to do is you're going to find f of int, but then you're going to add 0 and add -4, or technically subtract -4 from x and y respectively. And thus, when you do that, you are going to get, I'm going to run it through my calculator now, and there you have it. There are the answers to that problem. So you can see I did the integrals and then subtracted 4 from the y1. I would have subtracted the 0, which would have given me from the x, which would have given me the exact same answer. Alright, also, this is an important thing I forgot to do earlier. You should probably put the integrals from 3 to 0, just to specify. It's a good thing to keep in mind to do. Just think about it. Alright, so let's go on to D. I'm running out of time here, so I'm going to do this quickly. Find the total distance traveled by the particle over the time interval 0 to 3. Okay, let's do this. So how do you find the distance traveled by a particle? Well, the distance is, we would usually find, to find distance, we could use the integral of speed. And very fortunately, we already have found speed in A as the square root of dx dt squared plus dy dt squared. So let's write that out. Okay, so we have the integral from 3 to 0, because we have time of dx dt squared plus dy dt squared dt. And of course, again, this is one of those problems where you have that, and then you can just plug it into your calculator. For this, I have the equations already in my calculator as. So the way I would put this into the way I would do this is, just so you get an idea of how to plug this into a calculator. So for problem C, I already have the equations for dx and dt in my calculator. I have them in as dx dt is y1 and dy. Ooh, I'm running out of space down here. Dt is y2. So to plug this in for an integral, I would do fn int, because my calculator is one of those relics, and I would do square root of y1 squared plus y2 squared, because those stand for dx dt and dy dt, comma x, comma 0, comma 3, close parentheses. And that's how I would solve this, and then I would plug that in, and what would my